Well, facades are generally not designed to be stepped on, unless they are for Tom Cruise. No person or building was harmed during the making of this video. Okay. Back to business. Our societies need to actively strive for a sustainable future to address global warming and resource scarcity. Buildings play a crucial role in sustainable development, especially their skids, the building facades. Facades form the interface between the interior of the building and the outdoor environment. By having different materials, building orientations, shading devices, and advanced technologies, it helps optimizing indoor thermal comfort, and also the overall building performance. Facade efficiency is a new field of expertise that deals with climate and environmental challenges. We can lead the sustainable development in the building industry by using less energy and more adaptive facades, or even use facades to harvest energy.
Now, let's talk about different shading systems in facade design. Advanced, of course. First, materials, glazing. In a single glazed facade, 90% of the light and heat energy from the sun passes through, overheating the interior. Mechanical ventilation and air conditioning increases CO2 emission. Glare is also an issue. It is estimated that the curtain wall market will continue to grow, so it is necessary to choose efficient glazing systems. But with so many different types of glasses nowadays, which one is the best? Don't worry. Just remember these three main parameters. Let's focus on number 3. Here are some terms you must know. U value, solar heat gain coefficient and visible light transmittance. These are their optimal values in a hot climate area. Double glazing consists of low E coating that reflects heat, reducing solar gain in a hot summer day. In winter, the inner coating keeps heat inside. The cavity in the middle can be filled with low conductive gas. A typical double glazing fulfills the optimal values. Some new technologies include smart glass, which is switchable, BIPV, which acts as a transparent PV panel, and structural glass. 5 layers of ceramic materials are coated onto a thin piece of glass. Applying a small electrical charge causes lithium ions to transfer layers, making the glass tint. Reversing the polarity causes the glass to clear. The Nestle headquarters office in Switzerland was renovated in 2018. Smart glass was used to block excessive heat and light at certain times, while allowing the office worker to enjoy the great view. To further improve the performance of glazing as a facade material, the future development will be the combination of these 3 trending glazing innovations.
An energy-efficient building facade can help reduce the reliance of artificial lighting and HVAC systems to create occupant comfort in the interior space. This can be achieved by reducing excessive solar gain and improved ventilation. In the past, thermal comfort solely rely on the thermal mass of heavyweight material such as concrete and brick wall. But in modern days, double-skin facades can be used to achieve high thermal comfort in lightweight building structure. Double-skin facade, short for DSF, literally means a facade system with 2 layers. Glass is usually used to allow sufficient natural illumination. This distance of this cavity ranges from 20 cm to a few meters. The air flows through this corridor, creates an insulation layer against extreme temperature, wind and noise, thus enhancing the building's thermal efficiency. The airflow can be both natural and mechanically driven and is applicable in different climates. One of the most famous examples of this facade system is the Gherkin in London, UK. Designed by Foster and Partners, the building utilizes DSF to reduce its reliance on air conditioning and artificial lighting. Extensive use of glazing on the facade and light wells also enables natural lighting. The building uses only half of the energy consumption of similar-sized buildings. The tower is aerodynamically designed to reduce wind deflections and redirect wind into the facade system to facilitate natural ventilation. The air between the double-skin facade insulates the office space through passive cooling and heating. Openable panels in the facade draws in fresh air. The air that flows through the cavity and enter the office space through pressure differentials. In winter, the insulating effect keeps the building warm through passive solar energy. In summer, the outer curtain wall absorbs solar energy. Heated air rises through the cavity through stack effect and vent out of the building via openable windows.
The brise-soleil comes from the French word sunbreaker, that refers to the permanent shading technique ranged from simple concrete slabs and fins popularized by the Swiss architect Charles-Édouard Jeanneret, better known as Le Corbusier. There are 3 major types of brise-soleil. The horizontal overhang works most effective in the southern orientation that protect the building when the sun reaches a highest level. Vertical fins work well on the east and west side in the morning and evening. The egg crates is a combination of horizontal and vertical elements that has a high shading ratio and is very efficient in tropical climates. The Unite de Habitation is the first project Le Corbusier designed after the World War II. It was ideally a residential building that can house for around 1,600 people with mixed functions. He used a combination of horizontal and vertical concrete slabs as the brise soleil that they are associated to the loggias on the three sides, south, east and west, while the north side is a concrete wall that blocks the winter wind. In summer when the sun is high at noon, the system is effective to shade against the sun, and in winter when the sun is lower, it allows the sun to penetrate in. However, the sun shading devices facing east and west might not be as effective as those in south. It was tested that the west side allows a 2-hour solar penetration from 3 to 5 p.m. in summer and only 20 minutes of daylight enter the building in winter months. In contrast, the south elevation allows up to 8 hours of daylight penetration in winter and completely shade from April to September. In other words, the orientation is important for placing the fixed sun shading devices, and this project would work more effective if it is rotated for 90 degrees.
Adaptive facade can be defined as a building envelope that contains thermal or visual properties that vary passively or owing to an active control during different conditions, ultimately to improve the building performance in terms of energy and comfort. A similar concept of mur neutralisant was proposed by Le Corbusier in the early 19th century. The idea is to create a microclimate within the building by circulating treated air around the double-glazed facade and achieving the result of warm in winter and cold in summer. A vast amount of data of the exterior and interior condition is essential in the design process of an adaptive facade. In the case of Media ICT, a shade study was conducted, and it proved that shading devices are needed on both southeast and southwest facade. Also, an energy simulation shows that the facade system reduces 300 kilowatts of cooling power, indicating its great relevance due to the huge demand for cooling of 86% in the summer. There are two facade systems on the building. One is a set of lighting control system that is formed by ETFE cushions at the southeast facade, which the material is recyclable and maintenance friendly. They are fabricated in 3 layers, and each layer is printed in an opposite pattern. When air is inflated into it according to the exterior conditions, the air pressure change will overlap the pattern and deliver an opaque effect to control the gain of sunlight. A different system called CAC facade is serving the southwest facade. It is a 30 meters height vertical curtain of ETFE cushions that incorporates with a fog system. The cushions will be filled with fog when it is necessary, in order to mitigate the intake of sunlight in the summer. Adaptive facade shall play a crucial role when facing climate that is becoming more unpredictable, while its high cost of maintenance is yet to be improved for it to be widely used. Thank you.